My name is Ms.Dhivya Venkatachalam. I am working as an assistant professor in PG and Research Department of Physics. Today we are going to see the topic about astrophysics, in which I choose a peculiar topic, the stars. In next slide we have to see the classifications of stars. Stars are classified based on their spectral lines. Each of the spectral lines have peculiar color like red, blue, violet. Based on the absorption property of the stars, we choose this, we can classify these stars. In that the first classification system was proposed in Harvard classification system. They classified the stars in based on spectral lines of O, B, A, F, G, K, M. Of this, O is the hottest star, whereas compared to M is the coolest one. In between, based on the temperature, the stars are varied. In the case of O, the color of the star will be blue. When we observe in night sky stars, most of the stars are in yellowish color. This yellowish color stars are mostly placed in FG. In the time period only the stars only birth. So each of the classes having 10 subclasses, like in case of we choosing a spectral type B means B1, B2, B3 up to B10. Likewise O, B, A, F, G, K, M spectral classes are there. Based on each of the spectral line, the stars are classified. Stellar evolution. The stellar evolution is all about how the stars form, the mid-sequence and death of the star. Each of the star having a one peculiar temperature. Based on the temperature is due to the spectral line. At first the star formation is due to the collision of hydrogen atom. That is simply a nuclear fusion reaction, as we already knew, when the two lighter nuclei fuse it together to form a huge nuclei. So when the celestial bodies roll around the space, some few gravitational pull act upon the both of the hydrogen atom, means they get fused together and form a single atom. So at first in the star formation there is a hydrogen collision takes place. It takes place at minimal temperature. Minimal temperature means about below 100 Kelvin. After the star formation, we have a protostar stage. In this stage, people will say that in the protostar stage, stars give birth. The new stars will form. Already we have seen in the Harvard classification in some 7 spectral lines. Starting from each spectral line, the protostar stage starts. Next, after the protostar stage, pre-main sequence stage will happen. It will take about 10 million years, while comparing about even 1 million year is not imaginable in our routine days. If the star has to form, it will take up to 10 million years. So that on that stage, in the pre-main sequence stage, the star will form to give a little brightness, so that we see a dot of stars in the sky. So after the pre-main sequence stage, we have a main sequence stage. In that period, the visible stars only form in that period. So the temperature is about 3600 Kelvin. In that period, the only between star formation and pre-main sequence stage, only hydrogen atom will fuse together. In the main sequence stage, the star formation is due to the hydrogen and helium atom combination. So the nuclear reaction is so huge and the temperature is comparatively higher than the protostar stage, that is 3600 Kelvin. So after the main sequence stage, we have a red giant stage. In that giant stage, we have very yellowish color stars. Sometimes it may look like orange, visible region in our area. So after the red giant stage, we move to the white dwarf stage. In the white dwarf stage, the stars will die out of it, because the entire energy of fusion will run out and the stars will start to burn out and around in the space. Distance of the stars. Initially, when we look into our Earth, we may see the stars will locate in a huge distance, because our eyesight, based on our eyesight, the stars may look like that. But when we calculate based upon the Earth orbital rotation, the star will locate in a light year distance. 1 light year is defined as a light travel in vacuum of 1 year. When comparative to each and every star, they have a huge difference. When we move closer and closer to the stars, we may feel the distance. Astronomers use this light year to demonstrate the star distance and also to evaluate how old the stars are. Next. So, another method is parallax. Astronomers have developed various methods to measure the distance of the stars. It is one of the method as parallax. It is based upon the object distance. For example, an astronomer in space, he is about to see the Earth, stars and other planets revolving around in our Milky Way galaxy. The position in case of our Earth is considered as an object. From the object, what is the distance of the stars? That distance can be calculated by parallax. It is one of the method, and it is based on this parallax method is mostly based upon the Earth revolution, based on Earth revolution and distance from the stars to Earth. Properties of stars. Before stepping into the property of stars, we must have to know what are all the classifications in the stars. Based on the classification, the composition, size, mass, color, weightage, everything will be vary. In case of we take a blue star, that is Harvard classification. In which Harvard classification, we have a M type of spectral line. In that spectral line, the color of the star will be blue, while the coolest star will have blue, where the hottest have red. Following from red, violet, blue, green, yellow, the star color may be vary. The color variation is due to the composition in each of the stars, and the spectrum color in each of the star will based upon the hydrogen combination before the protostar stage. Brightness of the star. The brightness of the star may be vary due to many factors. In such few, intensity, the viewable person in space or an object, that factors may determine the brightness of the star, but the actual brightness can't be determined because the interior temperature is so much huge. So, we can't determine the actual brightness of the star. The apparent brightness is the star appear in the space, and the apparent brightness decreases from distance from the observer. Based upon the observer, the star color may be vary due to their visible power, and also to the visible person distant from the object to observable period. So, this brightness may change regarding to that. So, next one is composition. Each star has its own composition because if we consider the star formation is due to the hydrogen atom collision, each of the hydrogen atom having a unique property in space. The gravitational pull in same hydrogen atom will attract together and form a new atom that may be a star. It is visible when it observes the energy from spectral factors. So, based on the spectrum, each star has its own composition. The composition is generally due to the chemical element based in the protostar stage. In that stage, from protostar to white dwarf stage, the chemical composition changes according to the stages of the star. In protostar stage, the composition may be different and the interior temperature of the star may be different, but in white dwarf stage, the temperature runs out entirely, and there is no collision of hydrogen and helium atom. So, the composition may be entirely changes, and it's about 99% of stars mass to make up a new star. How stars form? Stars may be formed due to the cluster of atoms, hydrogen or helium atoms combined together. Clusters means generally we know clusters means a group of stars. Group of stars means that a group of spectral lines are united together in some particular space, that we called as a cluster. We may see in the space that we can observe the stars. Each of the stars are placed very close to each other. They are due to the cluster formation and its volume about to high. Some nebulas is one type of star. Some nebulas are glowing because of the composition in that element, that is photoluminescence based on the component. So, the nebula can be glowing. Next, the stars also formed due to the cloud of gas collide with each other. The cloud of gas is nothing but a hydrogen atom and a hydrogen atom collide with each other to form a cloud of gas which made of dust particles and also celestial objects in the space. Life cycle of the stars. Initially we have seen the classification, Harvard classification system. They classified O to M in the star periods from protostar to white dwarf stage. In the protostar stage, the star is about to give birth, that means initial hydrogen atom collision. The temperature become very much low in that protostar stage. When it attains a main sequence stage, the star is about to blink and emits the energy from it, because there is a huge collision of hydrogen atoms. When two atoms combine with each other, they will attract more element with respect to the gravitational pull. So, huge atoms combine to form a star in that pre-main sequence stage, and the dust particles and gases in the space is also helpful in the gravitational pull to form a star. The largest star are more energy produced. While we observe in a naked eye, we see a star as a minor point. In case of telescope, if you view it in a telescope, we can see the star's difference and rotations and the energy reactions in it. So, the larger star have more energy produced. The energy increase is due to the collision of hydrogen atoms, and the blue stars are burning brightly. It is due to the hottest region. Blue is the hottest region, while compared to red, it is a short lived stage. It is a coolest one too. Death of the stars. From protostar stage to pre-main sequence and main sequence stage, we must lift into the white dwarf stage and red dwarf stage. In that stage, the stars are unable to make a collision with another atoms, because the energy will entirely burn out. So, the compounds, the hydrogen and helium atoms in the stars are unable to make a gravitational pull, so that the energy will entirely run out. The temperature become too coolest, so the stars will burn out. Like when we able to see in the sky that asteroids, meteorites, a burning star moving around us, that's generally that's also a one kind of stars. So, the energy will entirely run out. They may after the death of the stars, the compounds may be celestial bodies or some comets or some asteroids, or it may be a black hole, it will turn out. So, this is the death of the stars. So, this topic is all about the stars. I think we have some ideas about the stars' birth, death, and how they are moving, and what are all the composition. So, thank you.